Welcome back to our channel. Today, we're diving into the fascinating world of computer hardware. In this video, we'll explore the physical components that make up a computer system. So, let's get started. Computer hardware refers to the tangible parts of a computer that we can see and touch. These components work together to enable the functioning of a computer and its software. Let's take a closer look at some of the key hardware components. Central Processing Unit, CPU. The CPU, also known as the processor, is like the brain of the computer. It executes instructions and performs calculations. Random Access Memory, RAM. RAM provides temporary storage for running programs and data that is actively being used. It allows for quick access and faster processing. Hard Disk Drive, HDD, or Solid State Drive, SSD. These storage devices store permanent data such as the operating system, applications, and files. HDDs use rotating disks, while SSDs rely on flash memory for faster access. Motherboard. The motherboard is the main circuit board that connects and holds together all the components of a computer. It acts as a communication pathway between the different hardware components. Graphics Processing Unit, GPU. GPUs are specialized processors designed for rendering graphics and accelerating tasks related to visual content. They are crucial for gaming, video editing, and other graphically intensive applications. Power Supply Unit, PSU. The PSU converts electrical power from an outlet into usable power for the computer components, providing the necessary voltage and current to keep the system running. Peripheral devices. These include keyboards, mice, printers, scanners, monitors, and other external devices that expand the computer's functionality. Network Interface Cards, NIC. NICs enable computers to connect to networks, such as Ethernet or Wi-Fi, facilitating communication and resource access. Cooling System. Computers utilize fans, heat sinks, and other cooling mechanisms to prevent overheating and maintain optimal operating temperatures. In addition to the main components, there's a lot more to explore in the realm of computer hardware. Let's briefly touch upon some additional topics. Expansion cards. These add-on cards enhance the computer's functionality, such as sound cards, video capture cards, and network interface cards. Input and output devices. These include devices like trackpads, touchscreens, joysticks, scanners, and digital cameras that allow users to interact with the computer. System bus. The system bus provides a communication pathway for exchanging data and instructions between different hardware components. BIOS, UEFI. The firmware embedded in the motherboard, known as BIOS or UEFI, provides the basic instructions and settings required to boot the computer and initialize hardware components. Storage devices. Besides hard disk drives, HDDs, and solid-state drives, SSDs, there are other types of storage devices. For instance, USB flash drives, also known as thumb drives or pen drives, offer portable and removable storage. Additionally, there are external hard drives, network-attached storage, NAS, devices, and cloud storage solutions. System case. The system case, often referred to as the computer chassis or tower, houses and protects the internal hardware components. It may come in various sizes and form factors, such as full tower, mid-tower, or small form factor, SFF. Power management. Power management features optimize power usage in computers, including sleep, hibernate modes and technologies that dynamically adjust processor speed. Cables and connectors. Various cables and connectors are used to connect hardware components together. Examples include SATA cables for connecting storage devices, HDMI or DisplayPort cables for video output, USB cables for peripherals, and Ethernet cables for network connectivity. Overclocking. Overclocking refers to the practice of running a computer component, typically the CPU or GPU, at a higher clock speed than its default specifications. This can result in increased performance but also requires proper cooling and may void warranties. RAID. Redundant Array of Independent Disks. RAID is a method of combining multiple physical storage drives into a single logical unit to improve performance, reliability, or both. Various RAID levels provide different configurations, including data striping, redundancy, and mirroring. Overclocking. Overclocking is the process of running a computer component at a higher clock speed than its rated frequency to achieve higher performance. This practice is commonly applied to CPUs, GPUs, and RAM, but it requires caution as it can lead to increased power consumption, heat generation, and reduced component lifespan. Cooling systems. To prevent overheating, computers employ various cooling mechanisms. These include heat sinks, which absorb and dissipate heat from components, fans that help circulate air, liquid cooling systems that use liquid to transfer heat away from components, and thermal paste or pads that facilitate heat transfer between components and heat sinks. Firmware. Firmware refers to the software code that is embedded in hardware devices. It provides instructions and controls the device's functionality. Examples include the firmware in a computer's BIOS, UEFI, firmware in routers and modems, and firmware in devices like printers and cameras. Multiple monitor setup. Modern computers often support multiple monitors, allowing users to extend their desktop workspace. Graphics cards with multiple video outputs, such as HDMI, DisplayPort, or DVI, enable connecting multiple monitors simultaneously. Virtualization. Virtualization technology enables running multiple operating systems or virtual machines on a single physical computer. It allows better utilization of hardware resources, isolation of software environments, and facilitates tasks such as software testing, server consolidation, and cloud computing. Firmware and driver updates. Hardware components often receive firmware updates to improve performance, add new features, or fix issues. Drivers, on the other hand, are software that facilitates communication between the operating system and hardware devices. Keeping firmware and drivers up to date can enhance system stability, security, and compatibility. Boot process. When a computer is powered on, it goes through a boot process. This involves the power on self-test, post, where the hardware components are checked for proper functionality. The BIOS, UEFI then initializes the hardware, identifies the boot device, and loads the operating system into memory for execution. Cache memory. Cache memory is a small, high-speed memory located close to the CPU. It serves as a temporary storage area for frequently accessed data and instructions, providing faster access compared to main memory, RAM. The cache helps reduce the time taken to fetch data from the slower main memory. Clock speed. Clock speed refers to the frequency at which a processor operates and is measured in Hz, Hz. A higher clock speed generally indicates faster processing. However, it's important to note that clock speed alone does not determine overall performance, as factors like architecture, cache size, and number of cores also play a significant role. Multi-core processors. Modern processors often feature multiple cores, which are individual processing units within a single physical chip. Each core can execute instructions independently, allowing for better multitasking and improved performance in tasks that can be parallelized. Server hardware. Servers are specialized computers designed to provide services, resources, and data to other computers over a network. Server hardware often includes features such as redundant power supplies, multiple network interfaces, and large storage capacities to ensure high availability and performance. Embedded systems. Embedded systems refer to computers or computing devices integrated into other products or systems to perform specific tasks. Examples include the computer systems in cars, appliances, medical devices, and industrial equipment. Embedded systems often have specialized hardware designed for their intended applications. Hardware compatibility. When building or upgrading a computer, it's essential to ensure compatibility between hardware components. This includes compatibility with the motherboard socket and chipset, RAM compatibility with the motherboard specifications, and power supply compatibility with the system's power requirements. Diagnostic tools. Diagnostic tools are software applications or hardware devices used to diagnose and troubleshoot hardware issues. These tools help identify faulty components, monitor system temperatures, check hardware health, and perform stress tests to ensure stability and performance. Hardware upgrades. Over time, hardware components may become outdated or require upgrades. Common hardware upgrades include increasing RAM capacity, replacing hard drives with faster SSDs, upgrading the CPU or GPU for better performance, and adding expansion cards for additional functionality. Disposal and recycling. Proper disposal of computer hardware is important to minimize environmental impact. Many components, such as batteries and certain electronic parts, require special handling due to their potential to harm the environment. Recycling programs and e-waste disposal centers help ensure responsible disposal of computer hardware. These additional details provide further depth on various aspects related to computer hardware, including boot processes, specialized hardware, compatibility considerations, and lifecycle management. Remember, computer hardware is continually evolving, so it's always exciting to explore the latest advancements in this field. A traditional hard disk drive, HDD, is a type of storage device that has been widely used in computers for many years. It consists of one or more spinning disks, or platters, coated with a magnetic material and arranged in a stack. The platters rotate at high speeds while read-write heads move across the surface to access and store data. Here's a more detailed explanation of the components and functionality of a traditional hard disk drive. Platters. The platters are circular disks made of glass or aluminum. They are coated with a magnetic material that allows data to be written and read from them. Modern hard drives usually have multiple platters, stacked on a spindle and separated by a thin layer of air. Read-write heads. Each platter surface has its own read-write head, which moves rapidly across the platter's surface. The heads are positioned above and below the platter and are responsible for reading data from or writing data to the magnetic surface. Actuator arm. The actuator arm is the mechanical component that supports the read-write heads. It moves the heads across the platters to the desired track, allowing data to be accessed or stored at specific locations. Tracks and sectors. The platter surface is divided into concentric circles called tracks, and each track is further divided into smaller units called sectors. Tracks and sectors form the basic addressing system for data storage on the hard disk. Spindle motor. The spindle motor is responsible for rotating the platters at high speeds, typically ranging from 5,400 to 15,000 revolutions per minute, RPM. The rotation speed affects the data transfer rate and access time of the hard drive. Controller board. The controller board manages the overall operation of the hard drive. It includes firmware that controls data flow, error correction, and interfaces with the computer's motherboard. Interface. The hard drive connects to the computer's motherboard through an interface such as SATA, serial ATA, or IDE, integrated drive electronics. The interface allows data to be transmitted between the hard drive and the computer. Caching. To improve performance, hard drives often have a small amount of built-in cache memory. This cache temporarily stores frequently accessed data, allowing for faster retrieval. Seek time and latency. Seek time is the time it takes for the read-write heads to move to the desired track, while latency is the time it takes for the platter to rotate until the desired sector is under the heads. Together, these factors contribute to the overall access time of the hard drive. Capacity and performance. Hard drives come in various capacities, ranging from gigabytes, GB, to terabytes, TB, or even higher. Larger capacity hard drives can store more data. Performance factors such as rotational speed, data transfer rate, and cache size affect the speed at which data is accessed and transferred. Traditional hard disk drives have been widely used due to their cost-effectiveness and high storage capacities. However, they are relatively slower compared to solid-state drives, SSDs, in terms of data access and transfer speeds. Nonetheless, HDDs remain popular for applications that require large storage capacities, such as mass storage, backup systems, and archival purposes. A solid-state drive, SSD, is a type of storage device that uses flash memory to store data. Unlike traditional hard disk drives, HDDs, SSDs do not have any moving parts. Instead, they rely on integrated circuits to store and retrieve data, resulting in several advantages in terms of speed, durability, and power efficiency. Here's a detailed explanation of SSDs. Flash memory. SSDs use NAND flash memory, a non-volatile storage technology that retains data even when power is turned off. NAND flash memory is organized into cells that store electrical charges to represent binary data, zeros and ones. The two common types of NAND flash memory used in SSDs are single-level cell, SLC, and multi-level cell, MLC, or triple-level cell, TLC. Controller. The controller is the brain of an SSD. It manages the overall operation of the drive, including data transfers, error correction, wear leveling, spreading data evenly across memory cells to maximize endurance, and garbage collection, reclaiming space from deleted files. NAND chips. SSDs contain multiple NAND flash memory chips. These chips are organized into arrays, blocks, and pages. Each page typically stores a fixed amount of data, while blocks consist of multiple pages. The controller interacts with the NAND chips to read, write, and erase data. Interface. SSD connect to the computer's motherboard via interfaces such as SATA, Peripheral Component Interconnect Express, or Non-Volatile Memory Express. These interfaces facilitate high-speed data transfer between the SSD and the computer. Read and write operations. In an SSD, data can be directly accessed from any memory cell, allowing for faster read and write speeds compared to HDDs. SSDs can retrieve data almost instantly, resulting in faster boot times, application loading, and file transfers. Durability and reliability. Since SSDs have no moving parts, they are less susceptible to physical damage caused by drops, shocks, or vibrations. This makes them more durable and reliable than HDDs. However, it's important to note that the lifespan of an SSD is determined by the number of program erase (PE) cycles it can endure. Trim command. The trim command is a feature that helps maintain SSD performance over time. When files are deleted or modified on an SSD, the trim command informs the drive which data is no longer needed, allowing the SSD to optimize its performance and improve long-term write speeds. Capacity and form factors. SSDs come in various capacities, ranging from gigabytes, GB, to terabytes, TB, or even larger. They are available in different form factors, including 2.5-inch drives for laptops and desktops, M2 drives for ultra-thin and compact devices, and PCIe-based drives for high-performance applications. Power efficiency. SSDs consume less power compared to HDDs since they do not require spinning disks and moving read-write heads. This results in improved battery life for laptops and reduced power consumption for desktop systems. Price and cost considerations. SSDs are generally more expensive than HDDs when considering cost per gigabyte. However, SSD prices have significantly decreased over time, making them more affordable and increasingly popular for both consumer and enterprise applications. SSDs offer significant advantages over traditional HDDs in terms of speed, durability, power efficiency, and overall performance. They have become the preferred storage solution for operating systems, applications, and frequently accessed data due to their superior performance characteristics. And there you have it, a glimpse into the world of computer hardware. We've covered the main components that make up a computer system and touched upon some additional aspects. Remember, computer hardware is continually evolving, so it's always exciting to explore the latest advancements in this field. Thank you for watching, and if you found this video helpful, don't forget to like and subscribe to our channel for more tech-related content. See you in the next video.